Today we're going to talk about multiplying radicals. I can perform any basic operation with a radical as long as the radicals are the same. I can't combine square roots and cube roots and fourth roots. I can only combine square roots with square roots and cube roots with cube roots. So before I do that, I want to talk about one specific type of problem. So we're just going to continue on our notes from last class. And my directions on these problems are always going to be simplify. Remember, simplify just means to clean up. So if I had to simplify, sorry you get to hear a nice background of my dog. If I get to simplify this expression, 2 times the square root of 300 x to the 4th y to the 5th. So whenever I do this, I go, okay, square roots. I need to know my perfect squares. So I'm going to come and I'm going to write down all my perfect squares. Fortunately for you, you have that blue piece of paper that you are allowed to use when you're doing your notes and your homework. However, on your test, you're not allowed to have it, so you have to be able to reproduce it really quick. So 1 squared is 1, 2 squared is 4. So I just write it all on the side of my paper. 3 squared is 9, and 16, and 25, and 36, and 49. And 8 squared is 64, and 81, and 100, and 121, and 144, and 169. 14 squared is 196. 15 squared, I don't know. What is 15 squared? 225. All right, so this 2 on the outside of my problem just means whatever I'm taking out, I'm going to end up multiplying by 2. So I'm going to pretend he's not there for right now. And I'm going to simplify 300 x to the 4th y to the 5th. So 300, the biggest perfect square that goes into 300. So 225 doesn't go into 300. 196 doesn't go into 300. 300 divided by 169? No. 369, I'm sorry, 300 divided by 144? No. 300 divided by 121? No. 300 divided by 100? Yes. 103. Square root, square root. So now square root of 100 is 10. The square root of 3 is the square root of 3. I can't do it. It's not a perfect square. So now I look at my exponents and I want them to be even. If I look at my even exponent, my exponent is 4, which is even, and I'm dividing it by 2 because it's a square root. If it was a cube root, I want to divide by 3, so I want to be dividing by multiples of 3. So I'm going to take my exponent 4 and I'm going to divide it by 2. 4 divided by 2 is 2, so x is on the outside. If I take y to the 5th, 5 is not even. I can't take 5 divided by 2, so I'm going to take one y out of that, and I'm going to change the exponent to 4. So now 4 is even, so now I can divide. So 4 divided by 2 is 2, so I have 2 y's on the outside. Notice that y right there is left over, so he stays inside. If I circle this as my answer, I'm losing a point because this 2 has to come down in front here. So if I put that 2 down in front, make it look like a 2. Notice there's no operation between 10 and 2. What is the only operation in math that's invisible? Well, that's multiplication. So it's really 2 times 10, which is 20x squared y squared times the square root of 3y. Okay? So if we go ahead and we look at another example real quick, I'll just quickly erase it so I don't have to refix my perfect squares. If I had negative 3 times the square root of 50 a to the 5th b to the 6th c. So okay, 50 falls between 49 and 64. So 50 divided by 49, no. 50 divided by 36, that doesn't work. If you don't know, you try your calculator. There's no judgment. Sometimes you don't know all these answers, and that's okay. 50 divided by 25. Hey, that works. 25 times what gets you 50? That's 2. Square root both sides. The square root of 25 is 5. The square root of 2, I can't do it, so it stays 2. Try to fix this 5. There we go. Look at my a's. Is my exponent to a even? No. So let me take 1 away, and let me change that by 1. Now is it even? Yes. So divide 4 by 2. I have 2 a's on the outside, and this a here, he stays inside. Look at my b's. Is my b's exponent even? Yes. So I'm going to divide it by 2 because it's a square root. So 6 divided by 2 is 3. Look at my c. Can I take c and divide it by 2? No. So c stays inside. If I circle this as my answer, I'm losing a point. How come? Because I forgot to bring down negative 3. And what do I do with negative 3 and 5? I multiply. So negative 15 a squared b cubed times the square root of 2ac. And this would exactly be the same thing if it was a cube root. I just would be dividing by groups of 3. So let me real quick do one problem where we do have a cube root, and then I will move on. So let's do the cube root of 24, a to the 4th, b to the 6th, c to the 7th. And let's put a 2 on the outside. So it's a cube root, so I no longer want to look at square roots. I now want to look at cube roots. So if I look at cube roots, I want to write down the perfect triples. Let me not write in yellow. So I'm going to do 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. If you don't know these, use a calculator. But you should have your blue paper in front of you to help you out. 4 squared is 64, 5 squared is 125. I'm personally going to stop because I don't think I'm going to need any number bigger than that. And if I do, I can always go back to it. So 24 falls between 8 and 27. So does 8 go into 24? Sure enough, it does. Cube root, cube root. So the cube root of 8 is 2. The cube root of 3 I can't do. So now look at my variables. Now because it's a cube root, I want my exponent to be divisible by 3. So right now is 4, which is the exponent of a, divisible by 3. No. Well, what if I took 1 away? And I changed that by 1. Sure enough, now it is. What's 3 divided by 3? 1. So I have 1a on the outside. Look at my b's. If I take b and I divide that by 3 because it's a cube root, what's 6 divided by 3? 2. So that cancels out. Look at my c's. Right now, can I do 7 divided by 3? No. So take 1c away and change that. So c now is divisible by 2. By 3 because it's a cube root. So 6 divided by 3, that's squared as well. And notice this a and this c don't have exponents anymore, so it gets brought down. If I circle my answer, I lose a point because I don't want to forget that 2. So my real answer is 4ab squared c squared times the cube root of 3ac. If I do not put that little teeny 3 to represent that it is a cube root, I'll lose points because it looks like a square root otherwise. So now let's go ahead. We're going to today talk very quickly about multiplying radicals. They look scary, but they're really not. Multiplying radicals is a subheading. Like I said at the beginning of this video, we can perform any basic operation, addition, subtraction, multiplication, or division with radicals. Today we're going to talk about multiplying. So what multiplying tells you is if I have the square root of a and I multiply it by the square root of b, all that does is make one giant square root and do a times b underneath it. So if I have two radicals being multiplied together, all I do is make one big radical, and then I just bring them down together. This works for square roots, cube roots, fourth roots, any radicals. Let's go ahead and let's look at an example. Let's do the square root of 8 times the square root of 12. Whenever I have two square roots being multiplied, I make one big radical, and I multiply them together. 8 times 12 is 96. So I got to write my perfect squares down again because I switched the paper. I'm going to stop here. 96 is between 81 and 100. 81 can't go into it. 64 can't go into it. 49 can't go into it. 25, let's see, 96 divided by 25. No, it's a decimal. What about 16? 96 divided by 16. Hey, that works. 16 times 6. Square root, square root. What's the square root of 16? 4. What's the square root of 6? I can't do it, so I write it. I'm done. Okay? So hopefully you're thinking that's not too hard, because that's really all it does. Let's try again. Let's do the square root of 2x squared y times the square root of 10x cubed y squared. So when I have two radicals being multiplied together, I make one really big radical, and I drop everything down underneath it, and I combine the things that are alike. So I'm going to multiply numbers with numbers. So 2 times 10 is 20. Over here I have 2 x's, and over here I have 3 x's. So I have a total of how many x's? 5. Over here I have 1 y, and over here I have 2 y's. So altogether I have a total of 3 y's. So now if I go ahead and simplify, I want to find the biggest perfect square that goes into 20. So 20 falls there. So 16, no. 9, no. 4, yes. 4 times what is 20? 5. Square root, square root. So I have 2 rad 5. Rad 5 is not a perfect square. Let's now look at my x's. I'm dividing by 2 because it's a square root. Can I do 5 divided by 2? No. So take one x away and change the exponent by 1. Now is the exponent even? Yep, divide. 4 divided by 2 is 2. This x stays inside. Look at my y's. Is my y even? No. Take a y out, change it by 1. 2 divided by 2 is 1. And then I have an extra y left over. And I'm done. If I erase this, I don't have to rewrite my perfect squares. Let's look at another one. What if I had numbers on the outsides of my radical like I did at the beginning of this video? What if I had 2 times the square root of 8x squared y cubed times 3 times the square root of 4xy? Well, I multiply like numbers with like numbers. So 2 and 3 are both free. They're both outside, so they get multiplied together. I am never allowed to multiply somebody who's inside with somebody who's outside. So 2 and 3 are both outside, so I multiply them, I get 6. So now my radicals, I make one big radical, and I drop everything down underneath. Like numbers get multiplied together. 4 times 8 is 32. Now look at my variables. I have 2 x's here, and I have 1 x there. So that makes a total of 3 x's. I have 3 y's here, and I have 1 y there, which makes a total of 4 y's. So 32 falls between 25 and 49. I promise my dog is not crazy all the time. It's going to work. Falls right there. 25 doesn't go into 32. 16. 32 divided by 16. Hey, that works. 16 and 2. Square root, square root. Square root of 16 is 4. Square root of 2 stays inside. Look at my x's. I'm dividing by 2 because it's a square root. Square root is even. Can I divide that exponent by 2? No. So take out an x and change the sign. 2 divided by 2, that makes 1x. And 1x stuck inside. Y to the 4th, what's 4 divided by 2? Well, that's 2. So y squared. And then I have to remember to take my 6 and bring it down. So my real answer is 24xy squared times the square root of 2x. If I was doing this with the cube root, I'd be doing the exact same thing. Sometimes somebody asks me, which is a really good question, is what if I had a problem like this? I'm not going to solve it because I think you'd be good to try some of these on your own at this point. But if I had a problem that looked like this, 3 square root of blah, blah, blah times square root of blah, blah, blah. Notice I have a free number here, but I don't have a free number there. What do I do? Well, if there's no number there, what number is really hiding? 1. What's 3 times 1? 3. And then I make one big square root and I bring down my two blah, blah, blahs. Okay? So go ahead. If you have any questions, make sure you come and you talk to me.